rows on your right were seeded using dibble stick seeding method, where after making a shallow furrow to clear weeds out of the planting site area, holes were made with the dibble stick set on about 3 centimeters depth, with the depth limiting rubber tire inner tube, bicycle tire inner tube. The first 5 rows in between this maize, which is only germinated in the last 2 weeks or so, about 14 days after planting, will be pigeon pea, or Cajanus cajan, widely used all over the world as a food legume and soil fertility improver. We'll be looking to plant 5 or 6 seeds per station to make sure we get a good stand, and to also make sure that the stem of the pigeon pea, which tends to get very woody if you plant it too far apart, doesn't get too woody by having the high population, 5 or 6 plants every 30 to 40 centimeters. That will make it much easier to manage next year. Instead of using a machete or a panga, you can actually use a grass slasher to cut that back. And the idea is that in November next year we'll come and cut the pigeon pea back after harvesting it during the dry season for either sale, consumption, or use as animal feed. All the green material that's there in November and the thin stalks will be cut and left on the surface of the soil. The leaves will fall off the stems, the dry stems, and start to rot on the surface of the soil, providing a green manure effect to the maize.
This is a shed or a storage for manure from the cow. So we make this with the local sticks, local pods from the bush. Then we provide the shelter on top.
Breakthrough has been, how do you manage to synchronize nitrogen release from the legume with demand from your crop? Because maize only really start needing nitrogen when it's 30-40 centimeters high. Before that it doesn't need hardly anything. It's only when it gets to this stage and starts growing into that 3-meter tall plant, that's when it really needs the push. So how do you synchronize it? And if you talk to the older farmers, the commercial farmers here in Zambia, where they used to grow sun hemp or velvet bean in rotation with maize, and you ask them, how much yield did you used to get? They'll tell you 2 or 3 tons of maize. And that's confusing, because you read the literature on velvet beans, and some literature says you can fix 200 kilos of nitrogen. Same for sun hemp. And if you equate that to fertilizer recommendation, which is 20 kilos of nitrogen for every ton of crop harvested, that's the standard recommendation for fertilizer in the tropics. 20 kilos of nitrogen equals 1 ton of maize. The issue with annual legumes is just that. You get the leaves, most of the nitrogen goes into the pod anyway when you harvest it, and then what's left gets left in the sun and volatilized. Okay? So by the time the rain comes, you've practically got none of your green manure capacity left. As you can see from this velvet bean I've just pulled out of the ground, it's already started forming nodules, which means it's starting to fix nitrogen from the atmosphere. In these pink nodules you can see here, and these house the rhizobium bacteria, which are able to take nitrogen from the atmosphere and convert it into plant available nitrogen.